Hi everyone, welcome to the Neo4j stream. My name is Will. I know it's been a little bit since I have been on the stream, but we're getting back into it today. Great, so thanks for joining. Today is going to be pretty fun. What we're going to do is take a look at importing data into Neo4j using GitHub Actions. So there's this really neat workflow that I discovered in the last couple of weeks with using GitHub Actions, and specifically a new action that the GitHub team released a couple of weeks ago called flat data. So we'll talk a little bit about what are GitHub Actions, how can we use this specific action called flat data to schedule periodic data import, so kind of like data scraping from a URL or from another database. And then we're going to use Neo4j Aura to import that data in the cloud into a Neo4j instance. And the data set specifically that we're going to look at is the lobsters data set. So lobsters, let me zoom in a little bit. Lobsters, this is like a social news aggregator. So kind of like Hacker News, if you're familiar with Hacker News. So you can submit articles and then they get voted up and down. And there's a front page that has kind of the hottest, most popular articles that folks are interested in. There's some comments and a comment thread. Each one of these articles has tags as well. So like this is an article about databases that is tagged scaling. Here we can see the other tags. So this is a really interesting data set to me because I've been thinking more about how do we surface relevant content to users based on their interests, and could we use this as a sort of news recommendation data set. And one thing that's really nice about Lobsters is they publish a couple of JSON endpoints. So if we just go to, and let me drop a link to the Lobsters chat too, so you can see what we're talking about here. So there's a link to the Lobsters site. And then specifically, Lobsters has a newest JSON feed. So this is a JSON endpoint that has the newest articles submitted. So these are not necessarily the ones on the top page. They go first to the newest feed, and then users can kind of choose to upvote, downvote, comment on these. Then there's this algorithm that is basically looking at what has a lot of points over a short amount of time, and that those sort of surface to the top and make the front page. So anyways, what we're going to do is use this Lobster's newest JSON feed, and what I want to do is periodically import this JSON file, because this is changing, right? This is not static. So as of right now, these are the newest, but as new people submit articles, we want to be able to capture those. So I want to set up some system where I'm capturing all the new articles that are being submitted and loading those into my Neo4j Aura database so that I can do some analysis, maybe look at the structure of this sort of social network, look at what are interesting articles. Can I figure out, based on articles you've submitted, other articles you might be interested in? This kind of thing. But really, we could do this with any URL using GitHub Actions. Cool. So before we jump into GitHub Actions, I guess let's start off by setting up our Neo4j Aura instance. So if you're not familiar with Neo4j Aura, this is Neo4j managed database as a service. So we can spin up Neo4j Aura instances in the cloud, kind of scale them up and down. We get a cluster depending on the workload that we need. Automatic backups are handled for us, monitoring, all of these things, upgrades. These are all sort of handled for us. So that's Neo4j Aura. However, there is also a free tier in Neo4j Aura. So that means we can spin up a Neo4j Aura instance without having to put in a credit card, and we get a free forever database. So this is great for these sort of side projects. I know, like a lot of folks, I have a lot of side projects going at the same time. So this is great to be able to have a database in the cloud for my side projects. So I'm already signed in to Neo4j Aura, so I'm just going to create a database. It gives me two options, Aura Free or the Professional. So Aura Professional, this gives me a Neo4j cluster with multiple instances. I can choose to scale the size of it up and down, but we are interested in Aura Free tier since this is going to be kind of a side project. And the theme, I guess, that I wanted to get across in this stream today is really no cost data scraping. So when we get to using GitHub Actions, we'll see that GitHub Actions also has a free tier. So as long as we're staying within that threshold, we can basically be able to scrape this data from the Lobster's news aggregator, import that into Neo4j, do some analysis, build a web application, whatever we end up doing with it, all at no cost, which I think is pretty cool. So, okay, we're going to choose our Aura Free. Let's give it a name. Let's call it, how about Lobster's Graph? And this is telling me the password. So I'm going to copy this password and save it somewhere else because we will need in a minute, and say, yes, I have saved that. And now we are provisioning our Aura instance. Great. So that'll take a minute or two to spin up. So while we're waiting for that, let's talk about GitHub Actions. So GitHub Actions, this is a feature of GitHub that allows us to trigger some code to run typically in response to a GitHub event. So if I have a repository on GitHub and I make a commit, someone opens a PR, typically we use GitHub Actions to do something like run the tests or trigger a deployment or something like that. And I can write my own code in GitHub Actions to define what I want to happen, or I can use lots of these pre-existing actions from the marketplace. We can see here a whole bunch of different GitHub Actions that exist that other folks have built and published that we can leverage. And we configure all of this using YAML, which is this markup language. We are specifically today going to use this GitHub action called flat data. Oh, and by the way, let me drop some links here in the chat. So that's GitHub Actions. Here's the flat data link. And let me drop the link for Aura as well. Okay, cool. So what is flat data? Well, there's this really interesting workflow that this guy named Simon Willison uncovered called the Django project. If you remember Django, currently he's been working on this project called Dataset, which allows you to share data sets and build APIs using SQLite, which is pretty cool. But he came up with this thing that he called Git scraping, which is basically, okay, if I have some URL that changes, the data changes over time. So in the example he's talking about in this blog post, which let me also drop the link to that in the chat. He was looking at fire data. And of course, as there's a new fire, as there's a new incident, the data for that is changing. And he wanted to see how this changed over time. And so he wrote a scraper that would fetch data from this URL and check it into version control. So check it into Git. And then you could see all of the diffs for how that changed over time. And there's a team at GitHub the office of the CTO called Octo, which I think is very fun. They took this idea and built this GitHub action that's now available in the marketplace, the GitHub Action marketplace, called Flat Data. And this is really cool because Flat Data allows us to basically just give a URL for our file. In our case, this is the URL for this JSON file that we're going to be working with. But it also works with a database. So if I want to run a query against a database and download that, we can also use that with Flat Data. But it allows us basically with just some configuration and pointing at this file, say, hey, fetch this every hour, every 5 minutes, whatever. Fetch that, check the file into version control. So check it into Git, push it up to GitHub, and then I can look at the diff to see how that file changes over time. And there's some other things in here that we can also do some post-processing. So we're going to use something like this feature to import this data. Every time we fetch the data, we're going to import it into Neo4j. And there's also a visualization component that this team built as well. Cool. So that is the plan. I guess maybe first of all, should we start with the flat data scraping? Maybe that's a good place to start. So I'm going to go to GitHub and create a new repository. And by the way, if anyone has any questions or wants to chat, feel free to drop a message in the chat. I can see those on the other screen here. So let's create a new repository, and this is going to be the repository where we're going to define our GitHub action and where the data for the lobster articles is going to be checked in. So let's call this, how about lobster graph? And this is going to be importing data into Neo4j Aura using GitHub Actions, and specifically data from lobsters. Make this public, and let's add a README so we can start committing to this right away. I'm going to try to use just the embedded editor in GitHub. We'll see how that goes. Okay, so should we look at an example? Maybe let's look at an example for flat data. So this is importing Bitcoin price data. And if we see here, see this .github workflows directory that has this flat.yaml file. So let's zoom in on this so we can see that. And we move this over here. There we go. So, okay, so here's this example. So this YAML, this is defining an action, and we're defining the triggers for the action, and then the steps for the action, which is basically just to use the GitHub flat action, and then fetch this URL and save it as this file, and then run a post process. So there's a JavaScript file that says, after you fetch this data, here's what you're going to run. So let's create that for ours. So I'm just going to use the editor in GitHub. We'll see how that goes. So create a new file. And we want this to be .github workflows, and let's call this lobsters.yaml. So we need to give this a name. Let's call this the lobsters data import. And now here we're defining the triggers for this action. So anytime there's a push, I guess specifically anytime there's a push to this configuration file. So anytime we're changing the configuration for the action, let's run it. So anytime there is a push to any of these paths, and it's just going to be .github/workflows/ this file, lobsters.yaml. We can also manually trigger this. So if we say workflow dispatch, that allows us to go into the UI and click a button, I think, to manually trigger this. And then here's the really cool thing is that we can put this on a cron schedule. So we can say every, maybe let's do what, every hour? That's probably often enough. So that, I think, is the cron tab syntax for every hour. The most rapid rate that we can do these on GitHub is, I think, every 5 minutes. And by default with GitHub, you get, I think it's 3,000 minutes of GitHub Actions on your account. So think of, and of course you can, and that's for free. And then of course you can pay beyond that. So we want to keep our total minutes of action running to less than 3,000 per month, unless we have a reason to increase the frequency there. I have a bunch of other things running, but I think once every hour should be good. Okay, and now we're going to define the jobs for this action. So let's call this scheduled, and we can define the container that this runs on. Let's just do this on the latest Ubuntu, and then we define the steps for our action. And so the first thing we'll do is check out the repo. And this is going to use a specific action from the marketplace called checkout, and that's just going to check out the repo because we want to be able to commit the data back. We want to be able to access the data and so on. So we need to check out the repo, and then let's call this one fetch newest. Let me zoom in a little bit. So this is hopefully a bit more readable. There we go. So fetch newest. And this is going to use the GitHub Octo flat data action. And here in this with scope, we're going to define some variables. Specifically, we need to specify the HTTP URL. So this file that we want to download every hour. Is lobsters/newest.json. And then we need to save that as newest.json. Okay, so I think that should be enough here to fetch this file with flat data. So let's commit this. And if we go to the Actions tab, we can see, yep, here's this action that we created. And it's starting to run here. So first time this should run and fetch our file and check it into this repository. And if we go back, cool. Yep, looks like it did. So newest.json is now checked in to our GitHub repo. Cool. Okay, so now the next thing we want to do is think about how we're going to get this into Neo4j. So let's jump over to Neo4j Aura. And our Neo4j Aura instance is ready to go. So let's open up Neo4j browser. And I guess first of all, let's just take this file and think about, okay, we have this JSON. How are we going to import that into Neo4j? So let's see how we can use the APOC, so the standard library for Neo4j. Let's see how we can use that to pull this JSON file into Neo4j and see how we can create data in the graph for what we're interested in importing. About lobsters is that it has an invite graph. Let's see if we can find this. So lobsters, you have to be invited to be able to submit stories and make comments on it. And that is public. Everyone who has invited users, the full user tree. And so this is public. So we can see everyone who has been invited to lobsters, who invited them, and so on. So this invite graph, I think, makes this a bit more of a friendly community, I think, since you basically, everyone sort of knows everyone else to some degree. And this would be an interesting graph to pull in. I think we'll maybe look at that in the next session. But that is what this invited by user is here. So this is saying that this user, Jordy GH, he was invited to lobsters by this user. So we can pull that in as well. And then each article has some tags. So if we go through the graph modeling process here, let's think about this. Well, we're going to have a user, and the user has a username. That's a string created at date. Let me zoom in a bit. Hopefully that's big enough. Created at, this is going to be a date time. Is admin. I don't know if we need that. Let's bring in the about. That's a string. User has karma. So you earn karma as you post articles. Other users vote up on it. Other users upvote your comments. That is karma, which is an integer. We have an avatar URL. And then we said that a user is invited by another user. So we'll model that this way. So user is invited by another user. And then the other entity we have are articles. So articles, user, let's say, submits article or submitted. And then for the article, what do we have here? So an article has a ID, it's called short ID. We'll keep the lobsters term. So short ID, it has a created at, that's a date time. What else? A URL, that's important. A score, that's important. That's an integer. And then each article has one or more tags. So let's model that as well. So a tag, this is like some category for the article. So in this one, this article about prime numbers, the tags are games and math. So we're going to use tags as some way to figure out what this article is about. And later on, if we want to build recommendations with this data, those tags are going to be really useful to see if we can figure out what users are interested in. So a tag, I guess we'll just say that a tag has a name. Oh, and then article, let's say, has tag. Cool. So here's our graph model that we want to create based on the data that we have. So let's jump back into Neo4j browser now for Aura. I copied the wrong password. So the URL is lobsters/newest.json. And we're going to say yield value. So value is now this object that represents the parsed JSON object. And let's just return that, make sure that that works. And we should get back, this is what, 25 rows? Yeah, so we get back 25 records. So this parsed JSON object, and let's slide this over here so we can zoom in a bit more so the font's a bit bigger. Maybe that's easier. Okay, cool. So this is just the JSON data that we're looking at over here. So now, instead of just returning this, let's start to create some data. So what we want to do is for each one of these articles, create some things in the graph. So we're going to unwind this array object. Let's say as article. So unwind value as article. So now article refers to each one of these objects. And first, I guess, let's merge on the user. So merge, if you're not familiar with the Cypher command merge, this is like a get or create or like an upsert. So it allows us to say, check to see if this pattern exists in the graph. If it doesn't exist, then create it. If it already exists, then just select it, just match on it. So this allows us to write these import scripts that are what's called idempotent. So this is really important because we're ultimately going to be running this import script every hour. So we want it to be idempotent so that if the data hasn't changed, then no data in the database changes. And merge is really useful for allowing us to do that. So we're going to merge on user. We'll alias this user to S for the submitter, I guess is a good way to think of that. And in the merge pattern, we want to merge on the property value that identifies uniqueness for the user, which in this case is the username. And that is here. So this is going to be article dot submitter user dot username. I'm going to zoom out just a little bit so we have a little longer. Actually, let's move this up to the top, and that'll give us a bit more room. There we go. Okay, so merge on the user, and then we're going to, let's say, on create set. So only in the case where we are first creating the user do we set these values. Actually, we have some things that change here. So karma can be changing. So with a merge, we have two options. We can say merge and then set some values, and we can do that if we just say like this, merge and then set. We're going to every single time that we execute this merge operation, we're going to update these property values. But we could also say on create set, which means only in the case of the first time you're creating the user. But I think some of these might change. Certainly karma can change. A user can update their description. They can change their avatar URL. So let's just set all of these each time. So we'll say set created is going to be cast to a date time, the article dot submitter user dot created at s dot karma. Let's bring that in. It's going to be article dot submitter user dot karma. So because we're using APOC load JSON here, we don't have to cast this integer to an integer. That's handled for us, which is quite nice. If we're using something like load CSV, then we would need to cast any data type that's not a string. Here we're passing the created at timestamp to the datetime function, so that's converted to a datetime type in the database. What else? We have the about, so the description, submitter user dot about, and avatar URL. That's a good one. Submitter user dot avatar URL, and let's add the lobster's domain in front of that. So we have the full URL. You can see here it's just the path without the domain. Okay, that's probably enough for the submitting user. Next, let's merge on the user that invited this user. So if they merge, this one is going to be I for invited, article dot submitter user dot invited by user. I'm just looking at our document over here. And then we'll say this user invited by I. Oh, I've got the backwards. The submitter was invited by I, the inviting user. Okay, so that'll create this relationship between the inviting user and the submitting user if that doesn't exist. So now let's do another merge on our article. So what is the property value that identifies uniqueness for the article? I guess that's going to be our short ID. It's the article dot short ID. And let's go ahead and update these. Again, we could use onCreate sets, but these values can change over time for the article. I guess the score gets voted up. Sometimes the title could be changed. So let's just go ahead and update these each time. So the article URL we care about. What else? The score. Article title. And there's a URL for the comments. That's important. We might want to scrape the comment data later on. What else do we have? Oh, the created at date. So we'll pass that again to date time, article dot created at. Okay, so that's going to create the article node and then merge to say the submitter submitted the article to create that relationship. And then the last thing we have here is the tags. So we're going to unwind over this array, this tags array, and do another merge to create or find the tags if they already exist and connect the tags to the article. So let's do a with here just to bring through the article, which is the JSON object, and A, which is the article node. And we're going to unwind over article.tags as tag. And merge on the tag, and then merge on this pattern that says the article has tag T. Okay, let's give that a run, see if that works. Nope, syntax error. On line 15. We forgot a comma on the previous line in our set. Let's try it again. Okay, so we created 104 nodes, set a bunch of properties, created a bunch of relationships. Let's match on all our articles and return them. Okay, so here is an article. If we double click, we can start to traverse this. So this is an article, thoughts on racket and cheese scheme. I don't know what that is. Scheme, oh, something to do with Lisp. Okay, cool. So this article has a tag. We can see other articles that have the same tag. So other things about Lisp. You can see the users that submitted the article and who invited that user. Cool. So I think that is what we wanted to create in the graph. So we could go a couple of ways now. We could maybe play with something like Neo4j Bloom to try to start to make sense of this visually. We could look at start analyzing some of this data. Could we figure out recommendation algorithms? But I think we need a bit more data. And so what we want to do is set this up to scrape this data over time. So we said every hour we want to import this data into Neo4j. So all we've done so far is write this single Cypher statement that fetches this URL, this JSON file, and then creates the data in the graph. But we want to run this periodically. And so this is where our GitHub action comes in. So we're going to go back to GitHub. Let's copy this Cypher statement. This will be valuable for us in a moment. Copy that. And now what I want to do, let's see, where is our GitHub repo? Here it is. So now what I want to do is take a look at this post-process option for flat data. So one of the options here that we saw is we can run a JavaScript or a Python file after our GitHub action run. So we set this up to run every hour to download the JSON data, check it into GitHub. We could write a script to using the Neo4j JavaScript driver to run our Cypher statements, load the JSON file that's been checked into GitHub, pass that JSON as a parameter, connect it to Neo4j, and execute that statement. So we could write a script to do that. But I already wrote a GitHub action that I thought just abstracted this away and made this a bit easier. That is in the GitHub action marketplace. So let's take a look at that. So if we go to search the GitHub action marketplace, I called this flat graph because it's designed to work with flat data, the flat data GitHub action. And so the way this works is after we configure our GitHub action using flat data to import the JSON file, we can then use this flat graph action. And all we have to do is define some credentials for our Neo4j instance, what file name we want to pull in, and then the Cypher query that we want to run. And so what this will do is we'll load this JSON file. pass it as a parameter to the Cypher statement that we define, connect to this Neo4j instance, and that will run every time that our GitHub action runs. So in our case, once every hour. So just kind of takes away some of the boilerplate. We could, again, just write a script to do that, but that's just the purpose of this flat graph GitHub action. So I'll drop a link to that as tutorial, and then we can reference them using that syntax in our GitHub Actions later on. So we want to create a few secrets here. One for Neo4j user, which is Neo4j. One called Neo4j URI, which is our connection string for our Aura instance, which is right here. And then one for our Aura password, which I will change this later, so don't worry too much about this showing up. That's fine. We'll change that after the stream here. Okay, cool. So now I've got Neo4j password, Neo4j URI, Neo4j user. And if we go back to our YAML file, let's edit this. And we're going to add a new step. Let's call this step maybe just Neo4j import. Oh, we need to give it a name. So Neo4j import. And this is going to use the Johnny Montana, so that's my GitHub username, /flatgraph version 1.2. So that's the flat graph GitHub action that we were looking at a second ago. And we need to define some values to pass to that. So we need Neo4j user. So I'll read that from secrets.neo4j user. We need a password, which we saved in secrets.neo4j password, and a Neo4j URI, which is our Aura connection string, which is in secrets.neo4j URI, I think we called that. We also need to specify the file name, which we said here is newest.json. And we need our Cypher query. So our Cypher query, this is a multi-line. So there are a few different ways to define multi-line strings in YAML, I think. This is one of them. And I need to go back and copy this query that we wrote again. So this query that we wrote again, we're going to use pretty much all of this, except for we don't need the epoch load JSON because we're reading it from a file and that is being passed as a parameter. So we'll need to modify this just a little bit. So here's our query. Let's indent this properly. So YAML parses as one multi-line string. So the only change that we should need to make to our Cypher query is instead of value with epoch load JSON, value is a variable, but in this case, we are reading this newest.json file and passing that as an Cypher parameter. That's what the flat graph action is doing for us behind the scenes. So that we just need to change the syntax here to say this, the $sign says that, hey, this is a Cypher parameter, so some value that's going to be passed with the query. Okay, so before we save this, so when we commit this file, that will trigger the action to run and we'll start importing data into Neo4j. Let's delete everything from our database so that we can actually verify that this actually worked. So I'll say match A, detach delete to delete everything. And there's nothing in the database. Okay, so I'm going to commit this change to our YAML file. And now this should trigger our action to run. So if we go to the Actions tab, we can see that, yep, it is running. And what should happen is we should fetch the newest.json, check that in to the repo, and then we'll run this Neo4j import step, which should load this data into Neo4j. So now, if we run this statement again, we should see some data. Cool. So looks like that worked. So here's the 25 most recent articles submitted to Lobsters, including the tags and the users, and then we're also seeing who invited those users. Cool, and so this is now scheduled to run every hour. If we go back and look at our YAML file, yep, it's cool. So this will run every hour to update the data. So now in the background, we've set up this scraping infrastructure to import all of the most recent articles from Lobsters, save that in Neo4j Aura. And once we have a bit more data, we can start doing some interesting things like trying to analyze this data set, maybe trying to generate some personalized recommendations. Let me drop a link to this repo that we just created if you want to see what we did. And again, this is just an example that we used with the Lobsters data set. I've been using this in the last couple of weeks for a couple of different data sets that I've been interested in. We can also do this for APIs. So if we have some API that we subscribe to, like I've been looking at the New York Times API, so that has API keys. We can also add API keys to our secrets and use that in GitHub Actions as well. I've also been looking at wildfire data, since that is particularly of mind right now. Cool. So I think that is probably enough to cover for today. Next time we'll have a week's worth of data, so it should be a lot more interesting. I think what I'd like to dig into next is maybe some visualization aspects of this. So can we build an interactive visualization to try to understand a bit more of this data set and of this network? So that's what we'll do next time. So I think we'll stick with the same Thursday afternoon US time schedule. I know it's been a bit of a hiatus for me on the live stream, but hopefully we can get back to the regular weekly schedule. Cool. Well, that's all I have for today. So thanks so much for joining. Have a good rest of your day, and we will see you next time. Cheers.